Okay, I'm going to find the area here between -1, x equal 2, the graph, and the x-axis. In other words, the shaded area. And I'm also going to find the integral. So I'll do the integral first. -1 to x cubed dx. It's x to the 4 over 4, evaluated at 2 and -1. It's going to be 2 to the 4th over 4 minus -1 to the 4th over 4. So we're going to get 16 over 4 minus 1/4. So 15/4. Okay, now I'm going to look at the area. And what I'm going to do is notice that this is going to be minus the area below. I'm sorry, yes, it's going to be minus a minus. So it's going to be negative. And then this integral, 0 to 2x cubed, is going to be the area above. In other words, a plus. So if this is going to give me the negative area, then this will give me the positive area, right? Multiplying both of these, this by minus and this by minus, a double minus makes it positive. That's going to be x to the 4th over 4, evaluated at 0, and, minus that, -1, that's going to be negative 0 over 4 minus -1 to the 4 over 4. That's going to be negative 1/4, so I get 1/4. Over here, 0 to 2, no need to monkey around with changing anything because it's already positive. I get 16 over 4, so this is area above, this is area below, so the total area equals area above plus area below equals 16 over 4 plus 1/4. I'm going to move that up just so you can see it a little bit better perhaps. That's 16, and that's going to be 17/4. Now notice if we'd added that negative to this, you'd get the same answer here. That's usually not the case because usually the term that we're subtracting, remember there's a 0 here, usually this term is not going to be 0. So it's going to be more complicated than it is here. Just wanted to point that out. So also want to show you how to do the absolute value. I've also said that the area is -1 to absolute x cubed dx. Okay. Now we're going to see that this gives us the same answer as what we had before. Sorry, that absolute should be like that. Let me write that better so it's clearer. Okay, now I need to figure out what the absolute value of x cubed is. That's going to be x cubed, where the function is positive, and minus x cubed, where the function is less than 0. So basically this is going to be equal to just plain old x cubed when x cubed is positive. That's when x is greater than or equal to 0. And that's going to be equal to minus x cubed when x is less than or equal to 0. Obvious from the graph. X cubed is positive over here, negative over here. That's all I'm saying right here and here. So this integral now becomes this, -1 to absolute x cubed. I have to break it into two parts where x cubed is greater than 0. That's going to, between -1 and 2, that occurs when x is between 0 and 2, right? That's where x is positive. And then plus where x cubed is less than 0 on this interval, -1 to 2, and that's going to be -1 to 0. And so for this integral, for this interval 0 to 2, it's equal to x cubed. For this interval over here, it's going to be minus x cubed dx. So I'm going to add these two together. That's going to be 0, 2, sorry, I wrote that in a funny way, x cubed dx plus x cubed dx from -1 to 0. So here, I should make that clear. This is going to be 0, 2 for this integral, and this is going to be minus 1 to 0. So that's how we get this and this. Okay. So, and this is precisely the same integral that I did on the last page to find the area. Bring the minus sign outside to make it easier. And so I get x to the 4th over 4, evaluated 2 and 0 minus x to the 4th over 4, evaluated at 0 and minus 1. We've already done this a couple of times. So what I'm going to get here is 2 to the 4th over 4 minus 0 minus 0 minus 1 to the 4th. And that's going to give me 16 over 4 plus, minus 1/4, and that's going to be 17/4. So the point is that this integral is equal to that, and that gives us this integral, and that's exactly the way that we did the area over here. We said this area was equal to this integral plus this integral. Okay? I hope that makes sense.